Hello, everyone, and welcome to the presentation of QUIX at this year's Photonics Plus. So, who is QUIX? We are a spin-off from the University of Twente, founded in January 2019, and have a team of experts up to 9 people and growing faster and faster. And let me say and start with our technology. Our technology is low loss because in quantum technologies, you need ultra low loss waveguides. We use silicon nitride waveguides with losses of 0.1 dB per centimeter and less. And also waveguide tapering for here, for example, fiber chip loss of 0.5 dB, which is needed to achieve the low losses of the devices we fabricate. And here you see an example of the cross-section of these waveguides. And furthermore, why is silicon nitride such a great platform for integrated quantum optics? Because this gives the scalability to larger peaks and more complex quantum applications, such as, for example, quantum computing. And also the wide transparency range is very important and makes it a versatile platform for many applications in quantum optics. To give just a few examples, it is easily integrated into photon sources such as quantum dots at 900 nanometers, or at, for example, 1550 nanometers with on-chip sources or spontaneous parametric down conversion sources. So what are our products? Our products are full photonic systems. Right now we have a quantum photonic processor, which is plug and play. So you generate input quantum state of light, give it to the processor, do the optical processing, and measure the output quantum light state. So here's an example setup of how such an optical quantum computer would look like. Here, it has basically 3 parts: the input quantum light source, the large-scale optical interferometer, which is on chip, on low-loss silicon nitride chips, and you measure the quantum output state of light. But what is important is to be versatile, is to have a programmable chip. And that is what we offer, a fully programmable chip. And sources are available, detectors you can buy, and we offer the fully integrated interferometer to the last puzzle for optical quantum computer. And also, we are happy to supply full integrated systems. So how does it look like? You have in here the multi-port interferometer. The hardware, it's completely controlled. It's thermally stable. You connect a computer, and via our control software, it directly translates all the voltages needed to control the chip into phases. And you can play multiple programs with one chip and even exchange chips. So let me show you an example of the programmability. We can achieve very high fidelities. What are fidelities? Fidelities is how certain are you that what you in theory dial, also what you get. And we see that we have here a fidelity of a very easy switching matrix, for example, of already 99%, and also the anti-diagonal. So if you switch port 12 to port 9, of almost 98%, and all kind of different switching matrices. These here are examples of the Pauli X gates, which are important for quantum optics, and also many others. And in average, we achieve, if you average about 150 such matrices, we achieve an average fidelity of 98% 98%. And this is only possible if you really understand what is going on your chip and how to control it. These are also the high fidelity values that are needed for quantum optics. But what can QUIX do for you? How can you engage with that? So what we want to do is we want to have these interferometers bigger and bigger. Right now, we are offering a 12-mode integrated photonic processor, but this will scale up soon to even bigger sizes, so stay tuned. Yeah, everything is controlled. We will build larger processes. We will extend our software to have the user such that it's easy for the user to simply dial the photonic programs he wants to program, and also increase the hardware to, when we scale up, to also have the high standards of transmission and ultra low losses. How can you access our QUIX technology? You can directly acquire our processor or our chips to test them, to work with them, to do your experiments. We are always interested in strategic partnerships and develop use cases with customers that want to explore the possibilities of photonic quantum computing and also do evaluation of such. Or we are also happy to fabricate custom devices for you for your quantum technology applications. And with that, I would like to thank you and would like to see you again later.